Welcome back to the next session of timer slash counter. So in the last class we have seen the what all the logic gates which are there inside the timer control block. So now we'll see the most important registers of timer slash counter. That is, first one is T mode register. T mode register that is called by the name called timer mode control register, and it is of 8-bit wide. It is of 8-bit wide, and this is how the bit pattern looks, right? From 0 to 3rd bit it is reserved for timer 0, okay, and from 4th bit to 7th bit it is reserved for timer 1. The names for a timer 0 bits and the names for the timer 1 are both are same, right? So we need to see what is the meaning of gate, what is the meaning of C/T bar, what is the meaning of M1, M0 now. So these the first lower 4 bits are with respect to the timer 0, the higher 4 bits it is with respect to the timer 1. So this whole 8-bit register is called by the name called timer mode control register, that is T mode register. So now we will take up the first one, that is gate bit. Gate bit, already you know about the gate bit. So when gate is equal to 0, when gate is equal to 0, the timer or a counter will be enabled if TRX bit will be equal to 1. This is first case as we have seen in the last, okay, and when gate is equal to 1, this is the second case, the timer slash counter will be enabled, right, if and only if INTX bar will be equal to 1 as well as TRX will be equal to 1. Am I right? So this is about gate, and the next bit is C/T bar. It is very simple. If it is equal to 0, then we are in timer mode. And if it is equal to 1, we are in what? Counter mode, right? So this gate is nothing but this gate. This is C/T bar is nothing but C/T bar, and this M1 M0 is nothing but this M1 M0. And if we are going to work with respect to the timer 0, we have to concentrate only on 0, 1, 2, 3. And if we are working with respect to the timer 1, we need to give the concentration only on 4, 5, 6, 7, the bit. Okay. Now the most important one the most important bits are here is M1, M0. So M1, M0 bits are called by the name called modes of timer slash counter. Since we have 2 bits here, so it can take the 4 combinations 0, 0, 0, 1, 1, 0, 1, 1. Please note, here we need to take M1 as well as M0, not M0, M1, right? So if the value of these two is equal to 0, 0, it is called by the name called mode 0, and this is mode 1 as usual, and this is mode 2, and this is mode 3, right? Next, mode 0, the name of the mode 0 that they have given is, it is called by the name called 13-bit timer mode. 13-bit timer mode, right? And mode 1, the name given for mode 1 is 16-bit timer mode, and for mode 2 they have given the name called 8-bit auto reload. 8-bit auto reload mode, and the last one is 8-bit split timer. Actually, it is the name given for this is split timer mode. Timer mode. So in further sessions we will discuss in detail how M0 works, in detail how M1 works, in detail how M2 works, and in detail how M3 works. So hope this timer mode control register is clear, right? So this is about the timer mode control bit register. So the next is we'll talk about the next register, that is TCON, timer control register. Again this is of 8-bit wide, and the bit representation for this the given is 0 1 2 3. So these 4 0 1 2 3, so these 4 bits are IE1, IT1, IA0, IT0. I stands for interrupt, E stands for external interrupt 1. So I stands for interrupt, T stands for timer, timer 1 interrupt. I stands for interrupt, E stands for external, that is 0th. Next I stands for interrupt, T stands for timer, 0 interrupt, timer, timer, external interrupt, external interrupt. So these 4 bits are used in order to control the interrupt, in order to control the interrupt. So about the interrupts we will discuss in the next chapter actually, but here we need to take care of these 4 bits. In detail we will cover these 4 bits in the next chapter. Okay, now the 4th bit, 5th bit, 6th bit, 7th bit. So these 4 bits are used in order to control the timer control bits. These 4 bits are used to control the timer, right? So TR0, TR1. As of you know the meaning of TR, timer run 0, 0 stands for timer 0, timer run 1, 1 stands for timer 1. TF0, TF1, timer overflow bit, timer overflow bit. So 0 stands for timer 0, 1 stands for timer 1. Now we will discuss one by one. Now we will discuss one by one. That is, first we will take TF1. TF1, timer overflow flag bit. Timer overflow flag bit. Timer overflow flag bit. So if I take 16-bit timer, if I take 16-bit timer, it can count from 0000H to 16-bit. If I take 16-bit timer, it will count from 0000H to the max value it will take FFFFH. That is, first it will take 0000, 0001, 0002, 0003 up to FFFF. Am I right? So the max value it can take is FFFFH, and when the timer resets back, I am using the word called resets back to 0000. When the timer resets back from max value to 0000H, automatically the timer overflow flag TFX flag will be equal to 1. It will make the value of TFX flag will be equal to 1. Hope the meaning of TFX flag will be is cleared. So if I take the 16-bit timer, it will take 0, 1, 2, 3 up to max value, that is FFFFH. When the timer resets back to 0000H, automatically the value of TFX becomes equal to 1. The meaning is, when the value of this becomes equal to 1, the programmer will come to know that the timer has been reset. Okay, so this is about TFX. TFX in sense TF1 as well as TF0. Next TRX I will call TRX, that is TR1, TR0. So if this bit is equal to 0, the timer is in disabled state, and if it is equal to 1, the timer will be in the enabled state. That means If it is equal to 1, the timer is running. If it is equal to 0, the timer has been stopped. Okay, so this is about TRX. So these four are covered now. Next is IE1. IE. So I will call IEX. IEX. So external interrupt. E stands for external interrupt, I stands for interrupt. So if this bit, when this bit will be set is, if there is a signal which is coming from high to low, if there is a signal which is coming from high to low, then automatically the value of IEX will become equal to 1. So external interrupt, it is with respect to the external interrupt. If there is a signal which is coming from high to low, then the value of IEX will be equal to 1, right? And if I take ITX, if there is an interrupt which is occurred on timer 0, then the value of IT0 will be equal to 1. Okay. So ITX, IEX is this bit is with respect to external interrupt, and this bit is with respect to the timers. Okay. So in timer interrupt, what will happen is, if IT0 is equal to 0, if it is equal to 0, then I will call it by the name code low level triggering. And if IT0 is equal to 1, then I will call it by the name code falling edge. Similarly, if IT1 is equal to 0, I will call it by the name code low level, and that means we are using low level triggering in order to start or in order to work with timer. And if IT1 is equal to 1, then it is nothing but we are using the low level triggering, like this. So this is about the timer control register, right? If you have any questions, you can put the comments. I will answer for those questions. Thank you.